Tonight's lesson is on 5.2 mixed numbers. So yesterday we had a review of fractions in class, and tomorrow you're going to be looking at mixed numbers. So as you can see here on the text, if you look at the next slide, is going to be showing pattern blocks, and what I want you to think about is the hexagon as being the whole, and then we're going to figure out what the fraction the other shapes are worth. So it's just important to remember that when we're talking about fractions, that you need to identify in the first place which shape or amount is going to be considered the whole, and then from there you can move on to calculating mixed numbers. So let's take a look at these shapes. We're going to say that this yellow hexagon is the whole, so that equals one whole. So if that were true, then let's take a look at, for example, these other shapes. So we have the equilateral triangles and the rhombuses and the trapezoid. So let's look at the trapezoid, and if we know that the hexagon is one whole, let's just move it and place it there, and we can see that if we put both of these on there that you would have a whole. So each trapezoid is worth 1/2. So let me just write that on there. Because we're remembering that this is going to be the whole. Or if we refer to 1, then the 1 is going to be hexagon, and the 1/2 is the trapezoid. So let's move on then and talk about, here we go, the rhombus. So if I slide this over, you can see, and I'll put one more on there just to make the point. You can see that 3 of those are going to fit onto the hexagon, so each one of them is equal to 1/3. So I'm just going to write 1/3. And then the last shape that we're going to look at is the triangle. And I put that right there, and maybe let's do a couple more just to see, and slide this one up here. You can probably figure out that I'm going to be able to fit 6 triangles on top of the hexagon. So each triangle is worth 1/6. So I'm going to take these back, and we'll go ahead and write 1/6 as the value for each of the triangles. Scooch that over. Oops. Very sensitive pen I'm working with here. So each of these are worth 1/6. All right. So let's go through just, I'm going to ask you a series of questions. So let's say that, I could pull together any of these, but let's just say that I picked 5 rhombuses, and I ask you to tell me the value of the rhombuses. So you could say, well, I know that if 3 of these equals 1 whole, then I'm going to have 1 whole and 2/3, because I would have 5 of them. So I think this is going to change. Yeah, it's not going to move with it, so I'm just going to leave that there. So you could actually put these together and physically show and demonstrate that 5 of them equals 1 whole and 2/3. So each time that you look at the rhombuses, you can think about the fact that 3 of them fit on the whole. And if I said, how about if I gave you, let's say 7 trapezoids? If you had 7 trapezoids, well, how many would that equal? So 6 of them is going to equal 1 whole. 6 of them will equal 3 wholes. So you could, again, just kind of visually put them in line and show me that visually. Or you could just go, well, I know that 2 of the trapezoids equals 1 whole. So if I have 6 of them, that's 3 wholes and 1 left over. So that would be 3 1/2, and so on. So now I am going to ask you a series of questions, and I want you to write these down in your notes and give me the answers for them. And in fact, I think what I'm going to do is insert one more new slide in here. And I'm going to just bump it up right there. All right, so here's your first question. If the triangle is 1/3, what shape is 1 whole? Okay, so you are going to think about that and write down your answer. And I encourage you, if you need some help, go back and take a look at the, let's just have this here for you. So we've got the triangle is 1/3. What shape is the whole? So you're going to go back to it and think, if I put 3 of these triangles together, then what shape would be the whole, and so on, okay? And your next question, the triangle is 1/3 again. What is the rhombus? Okay, so a slightly different question. Going back, if I go, the triangle's still 1/3, then what would the rhombus be? You could probably tell just by looking at it how many triangles will fit on the rhombus to be able to come up with your answer. Okay, next question. Scooch this over. If the rhombus is 1/3, what shape is 1 whole? Okay, so back over here again. If the rhombus is 1/3, what shape is 1 whole? That one's probably pretty easy because it matches with the very beginning of the lesson when we first started. I'm going to move this back on top of the triangle. All right, let's go back for another question. So of course you can always pause and go back in the video and pause to be able to look at the shapes if you need to do that. So just remember, you can stop, rewind, pause, whatever you need to do, but you're going to write these answers in your notes. Okay, so the next question. If the triangle is 1/2, what shape is 1? Okay, so this time, if the triangle is 1/2, what shape is 1? So if I take my eraser, come over here and get rid of the writing there, and let's say that now triangle is 1/2, what is the shape that is 1 whole? So if these two are 1/2 of something, what would be the shape that is 1 whole? And of course I'm referring to, it's going to be a shape that's already here. Okay, let's go back to the next question. Let's see what we have here. All right, so one more question. If the triangle is 1/2, whoops, what is the trapezoid? Let's see if I can make that fit on the same line. There we go. If the triangle's 1/2, what shape is the trapezoid? Or what is the trapezoid? Sorry, what fraction is it? So here's the trapezoid, and if the triangle is 1/2, let's go ahead and erase these previous values. Let's get rid of that, get rid of that. Oops. Okay, so if a triangle is 1/2, then what would be the value of the trapezoid? Okay, so that's your last question. Okay, so let's take a look at these rhombuses. And let's say that the value of each one is 1/3. Let's talk about the different ways we could name them. So one way is we could say, looking at them the way they're lined up right now, how we're seeing them, we could call this, oops, grab a pen. We would say, find it, there it is. We're going to call this 8/3 because we have 8 of them. All right, but let's do some moving around, see what else we could come up with. I could call it 8/3, or I could say, let's rotate that a little bit more, slide that in. Or if I line them up like this, instead of referring to them as 8/3, I could name them something else. I could call them, I've got one hole here and another hole here, so that makes, put a little comma there, that makes 2 whole, and I've got 1/3 plus 1/3, or 2/3. So that's another way I could name it. But that's not all. I could choose another name. Let's see here, come back here, comma there. Let's see, I could move these around, and let's say that I separate these like so. All right, so if I rearrange them in this way, I could say this is one whole, and since we've decided that each rhombus is worth 1/3, then I would go 1, 2, 3, 4, 5, call it 1 and 5/3. That's another way of naming it, naming this group of rhombuses. So now we're going to talk about improper fractions. So the way that we first wrote this right here, 8/3, we call that an improper fraction. And it doesn't mean there's something literally improper about it. It just means that the top number, which is the numerator of this fraction, is bigger than the denominator, which is 3. So 8 is bigger than 3, and whenever that happens, we refer to it as an improper fraction. Okay, I'm going to add another slide.